We will now start section 4.5 on integration by substitution. This is the last section in chapter 4. So once we complete this, we will be good with chapter 4 and all of our integration. Integration by substitution is exactly what it sounds like. It is, we're going to need to do some substitutions because it does not fit the only form we know, really, of x to a power or our nice special trig functions. So I'm just going to get started on doing the problems. Again, hopefully you have the notes that are on the Word document in e-learning to go through it. It has in there some guidelines on what we need to do. And the first thing we're going to do is choose a substitution. Your substitution is usually, not always, what's on the inside part of a composite function. Whatever is being raised to a power, whatever is in parentheses, something to that effect. Once you find your u, you're going to find your du, which is your derivative of it. Do substitutions that work, that make it fit back in, and then you are able to integrate. So I think it's going to be easier to kind of walk through a problem. So the integral of x squared plus 1 to the 50th times 2x dx. All right, this is obviously not just x to a power. So this is why our old method now does not work. Also, please notice this is back to an indefinite integral. I do not have values on the top and bottom of my integration symbol. So this is going to be plus c again. All right, so in order to do this, we're going to pick our u. Our u is typically what's in parentheses. So u is going to be x squared plus 1. Then we're going to want to find the derivative of that. So du dx is 2x. You're going to want to get du by itself. So multiply each side by dx. Du is 2x dx. Now we're going to want to do direct substitution for this. So I'm going to get the integral, and I will try to make this in color so you see and understand. X squared plus 1 is my u. So that is going to become u. I'm going to go back to the original because that u is raised to the 50th power. That is the same from the original function. Now, let me go ahead and say 2x dx is what is left. I don't know where that went. 2x dx is what is left in my original integral. Well, based on what we've done to now, 2x dx is the same thing as du. So I can get rid of 2x dx and substitute it with du. Now I do have a nice little function that I can integrate quickly. So once you have everything in terms of u, then we're going to integrate it. It should always give you a nice little function you can integrate quickly, or you did not choose your u properly. So the way we integrate, add 1 to the power, u to the 51st, over 51. Don't forget your plus c because, again, we are back to an indefinite integral. Now, my problem started with x's, so I want to finish with x's. I need to remember what u is. Remember, u, up over here, is x squared plus 1. So this is going to become x squared plus 1 to the 51st all over 51 plus c. That's what I'm looking for. That's the final answer. That is the integral of x squared plus 1 to the 50th times 2x dx. All right, let's do another one. Number 2. Let me erase this. All right, so let's do the integral of the sine of x plus 9 dx. So this is not one of our basic trig functions, so we're going to go ahead and use u substitution for it. If our angle is not just x, we're going to choose u to be our angle. So x plus 9 is our u. All right, take the derivative of that. It gives me du dx is just 1. We like to get du by itself. So I'm going to say du equals dx. Multiply each side by dx. So then that gives me my function, my integral of the sine of u du. That is what we like to see. So the integral of the sine of something, remember, is negative cosine of it. But again, because it is an indefinite integral, don't forget your plus c. So now plug everything back in. I'm going to get negative cosine of u. U is x plus 9 plus c. Done. That is my answer. All right, let's do another one. The integral of 1 over 1/3 x minus 8, all of that to the 5th dx. All right, well, this can be rewritten as the integral of 1/3 x minus 8 to the negative 5th dx. So that looks a little bit nicer. We're going to work with that one. All right, u is typically what's in parentheses. So 1/3 x minus 8. I need to take the derivative of that. The derivative of that is just 1/3. So that tells me du equals 1/3 dx. All right, so now I want to write everything in my integral in terms of u. So I get the integral of u to the negative 5th du. Oh, I do not get du. What do we get? So do not always assume something's going to happen. That is going to be u to the negative 5th. That is correct. But what do I have left? So again, let me go ahead and see what's going on with my colors here. All we have left is dx. That does not match up exactly with what's down here. I want this to be just dx, so I can substitute it in. I have 1/3 in front of this dx. I don't want it there. So how do I get rid of it? I'm going to multiply each side by 3. So when I multiply each side by 3, I get 3 du equals dx. So now I do have dx by itself. I can plug in for dx what dx is. Dx is 3 du. So up here I can get rid of my dx and multiply by 3 du. So notice on this top line, everything was in terms of x. Now on this line, everything is in terms of u. All right, let's make it a little bit nicer. So let me go back to my black pen. Remember, our constants we can pull out front. So I have 3 times the integral of u to the negative 5th du. And now I can integrate that fairly quickly. So I get 3, our constants stay out front. Integrate, add 1 to the exponent, so it becomes u to the negative 4 over negative 4 plus c. All right, so now we can go ahead and plug in what u is. So after you integrate, plug u back in. So remember up here, u was 1/3 x minus 8. Plug that in for u. So I get 3 times 1/3 x minus 8 to the negative 4th all over negative 4 plus c. But we need to clean that up. We don't leave negative exponents in our answer. So the 3 is going to stay up top. The negative 4 is going to stay in the bottom. Times 1/3 x minus 8. Now to the positive 4th power. Sorry, I wrote the wrong thing there. So that should be to the positive 4th power plus c. So this is the correct answer to that integral. I will do more of these and more interesting ones on one more video for this chapter.